Hello, everyone. Hello. Great to have you all here. Welcome to the final lecture of the Cyber School. Hugely excited for Dr. Bruhadeshwar's expert lecture on DDoS. Um, the recording has started now, and I don't want to make you wait too long before the lecture. Let me just get a couple of practicalities out of the way before I introduce Dr. Bruhadeshwar. Um, the doctor opened himself to a brief Q&A session in the end. So as usual, if you have any observations, any questions during the expert lecture, please by all means drop them in the chat box, which I enabled. If any of you has access issues, you can't type, no problem. Just send me an email with the questions and to my usual email address, like Ariane did the previous session, and we will be moderating and reading it out from there. With that, I would like to introduce Dr. Bruhadeshwar. Sir, welcome. Dr. Bruhadeshwar is a passionate researcher working on various challenging problems in the information security sector, program analysis, and networking domains. And he has already worked on various very difficult problems and published multiple innovative solutions in top venues. His experience pertains to the Indian Institute of Technology, Jammu, where he's currently a domain expert, and previously he was an associate professor of computer science and engineering. He was a professor at Mahindra École Centrale at Mahindra University. He was an adjunct faculty in an honorary capacity at the Indian Institute of Information Technology in Kota, a senior research associate at Colorado State University, and before that, he was also a university professor at KL University in a visiting capacity, a visiting research scholar at Nanjing University, an assistant professor at the International Institute of Information Technology, a graduate PhD student at Michigan State University, which is Dr. Bruhadeshwar's alma mater. Before that, earning his PhD and master's degree from MSU, Dr. Bruhadeshwar got his BA in Electronics and Communications Engineering at Muffakamja College. And with that, sir, I would like to yield you the floor. Very excited for your DDoS lecture.
Thank you very much. Thank you. So I'll just, there's a lot of pop-ups here. Okay, let me share my screen. Okay, so I think you can see my screen, right? So I'll just go to home.
Yes, sir. Okay. Yes, it's clearly visible.
Okay, so and also one update is I am also associate professor at the Southern Arkansas University at Magnolia in US. So that's another credential that I did not share earlier, but just wanted to share. Great. So I hope that all of you have enjoyed all the talks over the period of time. And, in fact, I used to give some earlier talks. This time, this is the final talk of this this session. But I'm always happy to, give talk in this forum. So we will talk about distributed denial of service attacks. So the reason I picked this particular topic is, although this topic DDoS is something that we keep hearing a lot, and DDoS is something that we may, even in general parlance and newspapers, we keep seeing that, Facebook is down, WhatsApp is down, all these kind of things. one has to wonder, what is happening, right? So how are these servers being brought down? And why do we keep seeing service disruptions in our PCs, in our whenever you're trying to transact on some website, suddenly your service goes down, you're unable to make the payment. You wonder like, okay, we are it should be perfect, right? It's a network connection. You have the service is clear. There is no issue. You shouldn't have any issues in even handling these. You shouldn't have any issues in completing your service, but still it's happening, right? So DDoS is something that is something of I would say a difficult, or I would say almost it's not just difficult. It's a very difficult problem to solve as such. And we would like to study why it is the case. So I will basically start with the structure of the DDoS, and I'll run you through few sample attacks out there, and then I will discuss how these attacks are even possible through botnets. I'll discuss about botnet structures and things like that. And I will also talk about some positive news about how to defend against such DDoS attacks. It's not that it's all bad. I mean, we can't do anything. I mean, many times it seems that way because we can only see a DDoS attack. We can only know that we are under a DDoS attack and only after it's complete, right? So only after you see the results. Okay. So what exactly is DDoS attack? So basically the idea of DDoS attack is simple. Find a target server. Okay, find a target server, and you simply launch a lot of you break into a lot of hosts around that server. So you compromise all these PCs around the targeted server, and then use these PCs as your army of attackers to send packets into the server. Now, what kind of packets? So the point is here, this attack is not originating from a single machine. It's originating from multiple machines. So that's why it's called as a distributed denial of service attack, right? It's not one single person who's attacking. There may be somebody who's telling all these machines to attack. That is something you need to think, like, how do these machines coordinate with each other and attack a single server? That's what we are going to discuss in the botnet, where there is a master or single master who actually tells these machines to attack. But the actual attack is carried out by these machines themselves. And these machines, they basically target this server and they send some packets. Now, the question is, will just sending some packets towards the target server, does it cause an attack? We don't know. Actually, the thing is, you need to know what you're sending also. So what kind of packets can you send that will actually cause an attack? And what is the attack we are looking at? We are basically trying to overwhelm this target, right? We are trying to overwhelm this target. There are multiple ways of thinking about what this word overwhelm means, right? So like, the first thing is, okay, this target is a server. So a server has memory, it has computational power, and it has network connectivity. So one possible way of overwhelming this server is, okay, send a lot of packets towards the server so that the network resources of this target are clogged up. That's one way. The second way is send something into the server so that the server is kept busy, right? It does a lot of computation. That's another way of looking at it. And the third way is send something in such a way that the server's memory is filled up, right? That's a third way of looking at it. And if you can launch an attack that does all of these three things, then you have pretty much achieved denial of service. So what is the denial of service here? The denial of service is to the legitimate users. So all these are malicious users who have just targeted your server and brought it down or have kept it busy. So if a legitimate user tries to access this target server at this point of time, then that server will find that the server that user will find that the server is busy, right? Let's say you're trying to buy something on Amazon, or you're trying to post something on Google, or you're sending an email on Google and the email doesn't get through. How many times have you seen that? You send somebody an email and then you don't get a reply. Sometimes you think whether the email is reached or not, or how long does it take for an email? So a lot of things come up in mind, right? So there are several reasons for that. Maybe the server was very busy at the time, so it couldn't receive this email, right? So this is what happens. The real people who want service from this server will not get it. Okay, and this is actually the basic idea of denial of service. So if the denial of service is caused by many PCs, that's what we call as a distributed denial of service attack. Okay, so typically network denial of service is you can cause it by sending a lot of packets directed flood towards the target server. You can use protocols like UDP, TCP, ICMP, and you can use common along with IP spoofing if you wish. But normally it's not required because IP spoofing these days IP spoofing is not really used for attacking. I mean, people use IP spoofing for different reasons, but for attacking, for launching DDoS, IP spoofing is not really that important. Okay, so but still you can try that, and people do network DDoS using what is called as reflected amplification. So effectively what happens is, let's say for example, you send a packet to something like a DNS, so let's say to a DNS server, right? Or like or something to like a network time server. Only thing is you can use IP spoofing to change your source IP to the target server IP address. So what happens is that in that case is that instead of you receiving the reply, the target server will get the reply, right? So if a lot of users send requests with the target IP, with the target server source IP, then this NTP or DNS server will actually send a flood of replies back to the target server. So that's like a reflected attack. And here even the bots themselves are not doing the attack. It's all these DNS and NTP servers are actually being used for this attack. Okay. You can do resource exhaustion, as I said. If you recall, servers are basically computing systems, right? So they basically have an operating system, and operating system is essential to run the, keep the health of the server. If you target the operating system of a target server, then basically that leads to a resource exhaustion attack. Okay, and the reason being that operating systems handle finite amount of resources. They don't have infinite resources. They just have, and they have specified limits on how much memory you can allocate to a given thread, how much memory can be given to a given process, how many threads can a given process launch. There are all well set boundaries or well set bounds for all these things. So if you overwhelm this operating system of a server, then you basically can launch a DDoS attack. Okay, so for instance, TCP SYN flood attack that we will discuss next, there is a limit on the maximum number of concurrent connections, right? So if you send many TCP connections, then the OS capability to accept new connections is exhausted. Okay, then you can have an ACK flood attack, wherein basically the ACK flood is, you send a lot of fake ACKs to a server. Okay, so so what happens with the ACK flood is that it's a different kind of attack. So whenever server receives an acknowledgement, it thinks that ACK is basically the TCP acknowledgement packet. So whenever a server receives an acknowledgement from in a TCP connection, the server thinks that there is an existing connection, right? Because the existence of an ACK means that there is a connection. Okay, so immediately the server starts searching for a corresponding connection in the state table. And all this is not non-trivial because the server has to first load the state table into memory, or it has to basically look up the state table. If the server is, if it's a large server which is doing a lot of connections, then the state table is not going to be trivial. It's going to be a very huge state table, right? And searching this, wastes the computation of the server, right? So that a kind of exhaust, and it is an operating system that has to do this job. So again, that wastes the server's resources. Okay. You can finally you can do resource service exhaustion. That is, you target network services like HTTP, DNS. For instance, simple HTTP flood. You send a lot of HTTP requests to the server. And so what happens when you send HTTP request, we'll see. We are going to discuss HTTP flood in more detail, right? So HTTP flood basically requires a server to do a lot of processing, right? So that means the web servers, let's say you have web server, right? So the web server will be processing the HTTP request. So of course, no web server can process infinite number of requests. So if you send a large number of requests, then the web server will be processing all this large number of generic requests. I mean, a request can be very simple request like, get index.html. it is absolutely useless. If the person who's making the request doesn't have any interest in actually seeing the reply, then there's not much, but the server still has to do work to send the reply back, right? So there's not much happening here. It's basically the server is doing work, sending the index page, but it's basically not being utilized. I mean, it's wasting server's time and resources, but it is not helping anybody else. So if the real users, they are trying to do some transaction on the server, they cannot do that because this HTTP server is busy handling all these, get index.html kind of requests. Then there are what is called as, you can do things like SSL TLS negotiation. So if you recollect, most web servers use HTTPS protocol, right? They use SSL TLS on top of the regular transport layer to secure the connection. So this SSL TLS basically is like, you can think of it like an encryption layer that sits between the application and the transport layer. So it encrypts all the data that is coming from the application layer, and then it sends it into the transport layer. Now the thing is, SSL TLS has a small flaw. The flaw is that the client can keep negotiating the encryption algorithm with the server. And when that happens, the server spends a significant amount of time trying to cater to the client's requests. And during this time, there is no real data being exchanged between the client and server. And in fact, because the server is busy with one client trying to change the parameters of these encryption and all that, the server cannot do real work, right? So it kind of exhausts the server's actual capability of doing its actual work. Let's say that server is Amazon and somebody is searching for sort of some products. The server is busy trying to, renegotiate these parameters of encryption with all these fake requests, fake clients. It will be unable to actually handle the real users' search requests, right? So this is something, which can exhaust valuable computational resources, and with a simple flaw in the packet, in the network, in the protocol, enables this, right? So this is something that can happen. Now let us look at some candidate attacks out there, like why DDoS is a serious attack. So the first attack is a very popular attack, and many people might already know this, but still it's a very interesting attack to study, right? So basically it's called as a TCP SYN flood attack. Okay, so it's basically the TCP SYN flood attack takes advantage. It's a multi-step. It takes advantage of the triple handshake process in the TCP. So TCP is basically the transmission control protocol. It's the workhorse for reliable data transfer on the for any internet protocol, right? So for any internet application. So that's how you actually receive all your emails intact, or how you receive your everything else, all the HTTP messages, or these, everything is intact, nothing is lost, right? So TCP runs everything. But to provide this kind of a reliable data service, TCP actually needs to establish a connection with the client, right? It's a stateful protocol and it's connection oriented. So stateful means both the client and server keep record of their actions, right? And they keep record of each other's actions as well, right? They keep memory of where the server, what the client sent so far. So server, for instance, keeps track of what the client has sent so far, and what is to be expected from the client, and so on and so forth. Similarly, the client also remembers what the server is doing, and what is expected. The second thing is connection oriented, meaning that a client and server cannot communicate with TCP unless they actually establish a connection. Okay, so what this means is that this connection requires both parties to actually allocate memory for holding the connection state, and then they can proceed. Now, the thing is, this is a multi-step handshake. That means, the handshake may not be completed all the time. Most of the times you can complete the handshake, but if you are a malicious client, you can actually open the connection, but you can do a half open of the connection, but you can stay inactive, right? So the connection, however, will stay active when it will remain in the state of the server until the other party becomes inactive. There's a window of inactivity, right? So this window of inactivity is sufficient. This basically is the attack. This window of inactivity where the server is waiting for the client to send something. That is a key attack parameter here. Okay. So the server doesn't do anything useful at the time because it's waiting for this client to send the final close the connection or complete the connection request, right? So this is the connection state of the client and server. So you can see here, this is the application which is basically kind of using the transport layer. And once the connection is established, you can see that there are a bunch of variables. We'll not discuss them like sequence numbers. There's a receiver buffer size. Then same variables are maintained at both the client and server. Okay. And this is the connection, how the connection happens. Initially, the client sends an initial request. This is the normal connection handshake, right? So there's initially the client sends a synchronized message to the server. Server is waiting for a connection. It gets a SYN packet. It will send a SYNAC packet saying that I received a synchronization acknowledgement. So it will just say that, okay, I have received your acknowledgement. It records the server's client's sequence number, and the server also sends its own sequence number. So the sequence numbers are actually used to keep track of the amount of data the client and server have sent to each other, right? And now the server, so you can see that this left hand side and right hand side, they indicate the server state. What state is the server in? Whether it's listening, whether it's in a send received, whether the connection is established or not. So when the client actually receives a SYNAC from the server, it sends a simple acknowledgement saying that the connection is now complete. Okay, so if this is a benign scenario, then everything goes well. But here's how the TCP SYN flood attack looks like, right? So I'll send the SYN packet. I'll send the server response back with the SYNAC. Now now you can see that this guy, the client, will forget to send something here. It doesn't send the SYNAC here or the acknowledgement packet here. And this is what happens. So server is in a state where it is listening for the connection. It is in the SYN received, but then it's waiting. What is happening here? Right? What is happening? So the connection is half open, right? So server will allocate resources because it has to store the sequence number. It has to remember the client's IP address, port number. So it will create a state table, right? It has connection state table, and all that will actually use up the server's resources. Okay. So that is a TCP SYN flood attack. Now, if a lot of clients do this, that's where you get the TCP SYN flood attack, right? So that's how the TCP SYN can be used for the DDoS attack. Now you have the HTTP flood attack, which is again, so HTTP flood attack is a very interesting attack. First thing is HTTP is stateless protocol. Okay, so that means it doesn't remember what it has sent to a given client in the last session. Let's say a given client sends a packet or sends a HTTP request. The server does not remember that, right? If the client sends the same request again, the server will respond as if it's a new request. It's a stateless protocol. Okay, so it works. However, processing HTTP requests can be considerably bad, right? Because it is depending on what type of request it is, the server has to spend sufficient amount of time and sometimes resources to process the request. So the flood attacks looks simple, is like this. Having all DDoS attacks, they have the basic structure is very fairly straightforward. Multiple bots, multiple compromised PCs attack one single server. Okay. Only thing that changes is what are the PCs said, what are the bots sending to the server. That's the only difference in the different attacks. So it's basically an application layer attack, and its intuition is simple. It keeps the server busy, right? So there are two types of HTTP attacks. One is the get, other is the post attack. So what is a get attack? So get and post are actually HTTP methods, right? So you can use these two methods to send data to the server. These are two methods in which you can actually send requests to the server as well. So get and post, of course, have different connotations. Get is to get something from the server. Post is to actually put something into the server. Okay, so for instance, how does GET work? So if I send if multiple bots send requests for images, files, etc. on the targeted server, then the server will actually get flooded with multiple requests, right? It just gets flooded with these requests and DDoS will happen. In fact, if you think about it, all these requests need not even be for legitimate images, files, or resources. They can also be for something that don't exist on the HTTP server, right? The server still has to search for those resources on its local database and then see if they are found or not found. Right? Even that wastes time for the web server. Only thing is you should be able to send a lot of these requests. Okay, that is a key aspect for a DDoS attack. And in a post attack is much more complicated in a sense that it is much more simple in sense. So because you're sending some data into the web server, and the web server might have to actually process this request, search some database, backend database, and then it has to actually run the database commands and things like that, right? So handling a post request actually has two parts. One is the form data itself, right? The server has to receives the form data, and then it actually parses this form and then tries to understand what the user is requesting. And then the server has to send some of this form data into a backend database, depending on what the user was asking. Okay. So again, the thing is, the creating a form or sending a form request into a HTTP server is fairly simple. You can, excuse me, you can actually do this without spending a lot of effort, right? However, if you the server itself will have to spend a lot of time in processing your request, and this causes the DDoS attack. Okay. And now, so let us see another attack. So the Internet of Things. So recently, I mean, not recently, let's say from 2014, 15 onwards, we've been seeing a lot of IoT, Internet of Things, right? So what exactly is Internet of Things? So the Internet of Things means these are smart devices which are connected to the internet and provide us different kind of services like Alexa or Google, this Amazon Echo. All these are services. All these are like, devices that can connect to the internet. They're not full scale PCs, but they have a small operating system and they have a small amount of they have an application code. They provide some service, right? So, and they're connected to the internet. They can use they can send IP packets. Okay. Now, the issue is that these devices, because they're connected to the internet, they become prime targets for attackers, right? So if you can compromise many of these devices, you can actually use these devices to attack the different servers. Okay, so why they become targets? That's because many of these devices, as I said, they have a small amount of they have a small operating system and a small amount of application code. Now, these kind of these devices, when this application code, or when this operating firmware is written, not much care is taken in the security, because the manufacturer is more focused on pushing the device out into the market, right? So the functionality is more important for the manufacturer. The manufacturer is not so keen on providing security. I mean, there are manufacturers like Amazon, Google, who do focus on these things, but there's a lot of other devices which can keep flooding the market, where manufacturers don't really pay attention to these things. And this is why IoT devices are prime targets for DDoS attacks. Okay, so we'll discuss this. So basically, the malware, so botnets are. We'll discuss about botnets in a while. So you can think of a botnet as a collection of malware, right? So it basically collection of viruses and stuff like that, right? Bad programs which can launch attacks. So the Mirai botnet basically is a malware that will actually scan for IP addresses and few IP addresses on ports 2323. It actually scans IoT devices or cameras. It actually scans DVR cameras. Okay, so these cameras had a vulnerability which Mirai actually exploited. Right. So once the device actually responds on this request to this scan request, the malware sends brute forces, send some password, user ID passwords to do a brute force login into the device, right? And finally, the device becomes a botnet, and it can participate in a large-scale DDoS attacks. Okay, so the Mirai malware, unfortunately, the Mirai malware botnet was discovered in 2016. It was in fact, even the Mirai source code was made public in forums. But that probably has led to multiple Mirai variants to come into the world. So now several variants of Mirai exist, and attacks continue on vulnerable devices. So there, it's a little more complicated. So attacks. We'll look at this traffic volume business. So this is basically the amount of traffic that was seen from these compromised devices at the time of an attack. So you can see that the volume is huge, 600 Gbps to 1 terabyte per second. That's one way to measure the DDoS attack. So here's the Mirai attack. So initially the bot will try to brute force a new victim. And once the victim is responding, then the bot will report to a server, and the server will actually then load a binary into this new bot victim. And so there's an infect command sent to the there are different servers here in this botnet. There's a reporting server, there's a loading server, then there's a command and control CNC server. Okay, so whenever the bot actually sends a report to a reporting server, the CNC server keeps checking the status of whether new bots are found. And when new bot is found, the CNC server will send an infect command to the loader. So this loader server is again a separate server. So the loader actually knows that, okay, some bot has to be infected. So the loader will send malicious binaries into the bot victim. Typically, these malicious binaries have to be, you have to send a lot of binaries into the bot victim. So usually this loader will use wget or, TFTP, trivial file transfer protocol, to do that. So what happens is when an already infected bot machine brute forces the new bot victim, it actually creates a shell code, or it gets access to a root shell on this particular bot victim. So that root shell is used for all this communication with the CNC server and the loader. Okay, so now this bot victim, once it is loaded with all these malicious binaries, it is ready to launch the attack of the CNC server. Okay, so when the time comes, the CNC server will simply send attack command saying that, okay, at this time, launch an attack on so and so IP address with so and so commands. It's like CNC server is more like a general, right? So the general will decide when the attack should happen and how many people should attack at which point, right? That's how it happens. Okay. So Mirai has multiple steps. So this is given by Jeffrey Voss of NIST. These steps have been identified by them. Of course, many people have analyzed Mirai. So I would first thing is, let me just put a disclaimer that most of the stuff on these slides, you can find in places on the internet, and I just most of the knowledge is such commonplace that I just I didn't put any references at this point of time, but many people have worked on all these botnets and things like that. Right. So Mirai botnet, for instance, there's an interesting piece by NIST. So where they talk about a 7-step process. So the bot first engages in a brute force attack to discover these weakly configured IoT devices. And once a discovery happens, the bot will get we gain a shell on this bot on this new device, and this device characteristics, etc., reported to a reporting server. Okay. And once that happens, the CNC server will actually, which is what is also called as a bot master, will check this target victim and the current status by communicating in the report server through Tor. Tor is basically the onion network, which is you. So we haven't talked about, we don't have time to talk about the Tor. Tor is basically a method for hiding communication, method for preventing tracking of servers. So specifically what happens is traffic analysis is easy if you know the source and destination IP addresses. But if a machine does not know where the packet is actually finally going, then you cannot actually track flows between any two machines, right? So Tor is actually a method. Tor is actually a network architecture which allows for this kind of anonymous communication on the internet. Okay, that's a topic for another day. But I think many of you would like to study the onion network, onion routing mechanism to understand how Tor works. So onion routing works exactly the way onions work, right? So there are layers and layers. So the actual packet is hidden in layers and layers of packet headers. So as a packet goes through multiple servers, the packet header is peeled off, right? So every time the packet goes through one machine, one packet header is peeled off, right? So, and while that keeps happening, once you peel off one layer, you will this machine will know the next machine to which this packet must be forwarded. Okay, unless if it is the final destination of the packet. Okay, but this is used by botnets to hide the location of the CNC server. Okay, so once the CNC server decides which devices to infect, botmaster will issue infect command, and with all to the loader with all the details like IP address, hardware. So it's a very structured way, and the loader will actually load the target device with different malware using WGA, TFTP, and things like that. And finally, the malware itself will try to protect itself from other malware by shutting down all these other points of intrusion like telnet, SSH. And finally, this bot is now ready for attack. Okay, and most of the times the bot actually resolves domain name to actually reach the CNC server. So the CNC server's IP address itself is hidden. So if the bot wants to talk to CNC server, it actually has to do a resolution of the domain name. So how does it help? How does having a domain name help versus a hard-coded IP address? Because domain names domain name can remain same, but IP address can change. And the only way we can actually only way one can learn about the new IP address is by actually doing a DNS resolution. So the CNC server can have one IP address today, another IP address tomorrow. So there's no really, what this means is that CNC server can actually be like a nomad going from one IP address to another IP address. So very difficult to track down, right? So people cannot figure out how to catch hold of this CNC server. Okay, they cannot shut down the CNC server because it keeps changing its IP address. Okay, and it's easy for the bots to find the CNC server because all they need to know is the domain name. Okay, so this domain name is sufficient for them to actually locate their CNC server. So for instance, cnc.changeme.com is the default entry in the Mirais found in the Mirais source code. Okay. In step 6, the botmaster can launch attack against a target server. It can give things like type of attack, duration of the attack, the IP address, and the target server. And finally, in step 7, at the given point of time, the target server, all the bot instances will start attacking the target server. Okay. Now, one of the important things you must remember here is that these bot instances, these computers which are infected, they are actually spread all over the world, right? So they have to be synchronized, and the synchronization business happens with the CNC server, which maintains its own timestamps for the attack. Okay, so that's how they actually succeed in launching a large-scale TCP flood and HTTP flooding attack. So now, if you go back to the previous couple of attacks we discussed, both those attacks can be possible if the botnet is available, right? So this is how these attacks happen. So the Mirai botnet is basically a botnet attack that can cause a DDoS attack. Okay, so let's just look briefly at botnets. Of course, this talk is not about botnets. I hope that somebody has talked about botnets in this session some point, but if not, this is a good point. I think this is a good place. So basically, botnets or it's a short for robot networks, meaning that there is one single master attacker who has compromised multiple PCs, right? This master attacker basically can now use these compromised PCs as a tool for launching attacks onto multiple networks, okay, or onto target servers. So this master can actually say that, okay, you can instruct all these machines to launch an attack, and then these machines will launch an attack on behalf of the master, right? So how is it possible for a master to compromise so many PCs? But the point is, many home and business PCs, they remain unsafe and insecure. And this is a very valid statement even today. right? Even with modern operating systems and modern knowledge of security, people still are not securing their machines. So normally attackers, if suppose the CNC server itself tries to attack a server directly, it'll get blacklisted, right? So botnets are best way. So instead of directly attacking the server, botnets, you can compromise these easy targets and then create zombies or bots to launch an attack. Okay, so these zombies act like anonymous proxies, and they hide the real identities, amplify their attacks. Okay, so of course there are many ways in which you can create bots and you can communicate with botnets. Like the internet relay chat, for instance, was the original method for creating and handling bots. Right, so the bot master would actually use this channel to communicate with the bots. So it was because it looked like legitimate traffic. Nobody will suspect that something is wrong with it. Like this, they don't think that it's a botnet related traffic, because IRC traffic is actually normal traffic. It is basically like this WhatsApp kind of traffic, right? It's like messaging app on the internet. Okay. So here bot software can basically now remotely control each system and then group them together as a zombie army. That's how it happens. So in fact, CERT has identified more than botnets with more than 100,000 members. That means there are PCs, botnets, huge botnets that consists of more than 100,000 people, right? And if suppose with these 100,000 members, let's say each of them launches 100 requests. In fact, they are capable of launching 1,000 requests per second, HTTP requests per second. So what does that mean? 100,000 into 1,000. That's like 1 million, 10 million, 100 million almost. 100 million requests per second, right? That's a lot. Okay. And in the world, more than 1 million bot infected hosts have been reported. They're reported, and I would say the number is at least 100 times more than this, or at least 10 times. Maybe 100 times is the exaggeration, but 10 times is definitely there. Within IoT, the number keeps changing. Okay. And Microsoft, for instance, has found more than 43,000 new variants of backdoor Trojans and bots. Right, so many bots are part of tier one. They use tier two, and they also form a hybrid IP network. And 64% of DDoS attacks are based on operators in North America, Europe, and Asia. Well, those are the major continents, but yeah. So we'll not talk about much about how botnets evolved because that will take considerable time. But basically, you can the internet relay chat was the application by which they evolved. Originally, it was just a basic method for communicating for connecting users, but then it was then exploited as time went by to create a method of grouping users together into a large group and then controlling them. Right, so this IRC channel was the first exploited to actually collect many people and then group them together, and then they make these machines do their bidding. Okay. So Eggbot, for instance, was one of the bots which Eggbot was actually a normal software. It was not a bad software. It was a benign bot, but it actually allowed all these nice things about collecting users together and grouping them together, linking multiple operators of different IRC channels, and you create a larger bot network. So all these things were there in Eggbot, and that allowed botnets to grow. Okay, so people exploited this scenario of this kind of method of creating botnets, and now botnets became reality. So once people realized that they could control many machines, they started. Once attackers realized this, they could actually use this method to launch attacks. Okay, so that's when, in fact, 93, 94, 95, that's when all the internet attacks happened, right? So a typical operation is the botnets, once they infect a machine, they download a series of script into a folder, and then the scripts are run with user privilege when they're connected to the chat server, and usually the bot will hide itself from being visible online. Okay, so that's something. Botnet infection is more like a malware infection. So the bot, once it infects your machine, you can pretty much assume that it will basically delete a lot of things from your machine. Okay. So there are many ways botnets propagate using operating systems, services, applications. And once a connection is established, the attacker can send many attack commands, and many scripts can be used inside there can be many scripts downloaded into this bot, which help the attacker to do a lot of things. Okay. So there are many types of botnets you can create, centralized, peer-to-peer, unstructured, and all that. Okay. So major attacks of botnets are DDoS and DOS. There are other attacks, espionage, spam, key logging, things like that. Okay. So some popular bots, you can see most of the popular bots like the Ego bot, for instance, has over 600 variants written in C++. And you can see most of the attacks are flooding attacks. DDoS SYN flood attack, UDP flood attack, HTTP flood attack. Similar things happen SYN attacks, SD bot, for instance, SYN attack, host, port, and time. Anyhow, this R bot, again, SYN flood, TCP flood, ICMP flood, ping flood, mostly flooding attacks. Okay, so then this spoofed spy bot has mostly, it's more like a stealth technique. Okay. Let's briefly go over the DDoS defenses. Can we do nothing? Detection is nearly impossible because only after DDoS attacks are actually seen, then you actually start realizing that you are under a DDoS attack. Okay, so from my experience, I mean, there are many approaches, but I just collected them into two different approaches. One is filtering, other is machine learning, right? So filtering is used in many modern servers and networks. So what is filtering? Basically, filtering is so many modern servers, they actually purchase some services from cloud services, or they purchase it from different protection, different companies that provide protection. So these servers actually deploy filters, okay, along the perimeter of the target that needs to be protected, right? So the filters keep track of flows and they count traffic going towards the target servers and networks. Okay. So the point is these filters act like some sort of monitors that keep track of what traffic is going towards the target server, right? So if I put like they're like sentinels, you can think of sentinels is the best way, right? So you put a lot of sentinels around you, they will kind of alert you to attacks, right? So the thing is, if at any point any filter determines there is an attempt to overflow the target server, the filter will block those IP addresses and it will, at least it may not block permanently, but at least for a while, right? So what are the challenges in filtering? So first thing is where to deploy, how far from the server you want to deploy, right? So is it too close to the server? The attack is already happening. If you put it too far from the server, you don't know whether the attack is happening along that path or not, because you're putting filters on network paths towards the server. And if those paths are not used for an attack, then the server is still under an attack. Okay. How many filters to deploy? Right? Well, again, this is a cost and performance. If you put too many filters, you have to pay money, and too many filters means performance is there. Okay. So these again are challenges. They have to be resolved at runtime. And most importantly, how do filters actually detect flooding in the first place? Right? That's not easy because DDoS flood attacks look exactly like normal data. Okay. So very difficult. People, if you are using deep learning, advanced deep learning and machine learning approaches to do this kind of differentiation. So one approach that we tried, for instance, recently was using Bloom filters. Okay, so the idea is that you keep remembering a lot of the IPs that are reaching the target server, right? So you remember a lot of these IP addresses, and if you see that at any given point of time, there are a lot of new IP addresses that are actually trying to target this server, then we actually block those IP addresses. Okay, the different challenges in this are like size of the Bloom filter, the number of Bloom filters and false positives of the Bloom filter. So if you're not familiar with Bloom filter is basically it's a data structure. It's in a you can use it for doing membership inference. It's a bit array with all initially zeros. Right, so then initially it's all zeros, so it has a size of m, and whenever you want to remember something inside a Bloom filter, you use these multiple hash functions. So these hash functions, you take the value you want to remember, like say hash of a, and you set that particular bit value to 1. Right. Similarly, if you use hash2 of a and you set that bit value to 1. So all these hash functions will set about some k bits. If there are n hash functions, send n bits to 1. So next time you want to know whether this hash function, if this value is already seen, you just use this hash function and see if all the locations are mapping to 1 or not. Okay, so that's how you know whether the IP is seen or not. Of course, there are issues about Bloom filters like false positives and all that, but you know, that's something that one cannot avoid. Okay. Then you can use machine learning approaches, classification. If you know, if you have previous traffic, you can use the traffic. You can use previous. You can use clustering. You can do association mining. A lot of things. So train the traffic, train the classifier on some input data and build it. But classification is not really a good approach for DDoS detection, because DDoS attacks, they're more or less you know, there's no difference between the real traffic and the DDoS traffic. Clustering is something you can do. What can clustering do? Clustering can actually maybe it can group traffic which is having similar patterns, right? DDoS attack may not be different from regular traffic, but the type of the frequency or the type of packets being generated, they could be similar, right? Because the botnet which is launching the attacks might have similar features. So this is something that you know, clustering could detect. Okay, so I'll talk about some aggregate features. So data like DNS data, net flow data, they can all be used for these kind of things. PCAP data, address allocation data, they can all be used to, you know, create aggregates. So let me see, I'm running out of time here. Let me just see. For instance,
you have time, sir.
Okay, okay. So I have the clock here. It's 6:51. So I'm just trying to, yeah. So a lot of these DNS servers, for instance, they can be used to detect botnet behavior. Like they keep seeing that, like say, let's say email spam, or if you know, if you see a lot of mail server record queries, query lookups, then you can, you know, kind of you know, assume that there's spam happening, email spam trying to happen, or even things like for suspicious domains. If DNS servers keep you know, popping up, so if I see that a lot of DNS queries are being sent for a given domain, like the CNC server domain, then that is suspicious, right? This is a botnet. Okay, so flow information is again another way. We'll talk about flow information shortly. Flow information is very useful to detect patterns in traffic. Okay. Packet data is also useful. Packet data is usually used for signature-based attacks, detection algorithms like SNOT and things like that, right? But packet data, if it is encrypted, then bot traffic, you know, it's difficult to detect. Apply signature-based approaches, right? Okay, so many times people use routing protocols like OSPF or address allocation protocols like DHCP to map bots or to find out the topology of botnets, right? So this is something people can do. Then we have what is called as host-centric detection, wherein some machines are actually, you know, they act like honey traps. They try to attract bot traffic. They try to attract CNC server traffic. These are not real machines. They're acting like real machines. And if any server, CNC server, or if any bot tries to brute force a honeypot, then the honeypot will behave in a fashion that will, you know, help the attacker to infect it. But it's not really a real machine. It's just collecting the information from the attacker, right? So that's how this honeypots collect data. And once the honeypot has enough information about this particular type of infection, then the honeypot can actually become active. You know, it can actually give input to the other methods like machine learning based methods to prevent this bot or prevent or detect these botnets in the wild. You can also look at a lot of host level data, but like antivirus operating system configurations or antivirus firewall logs, user activity. All this is very useful, but difficult to get hold of. You cannot get hold of everybody's PC and see what they're, you know, if you want to know if your machine is running a bot, one way to see it is just collect all this information, then analyze it. But point is, would you be willing to provide that data to somebody? That's the question, right? Some popular detection approaches do exist like bot hunter. They actually focus on cooperative behavior of multiple machines, and they actually use these cooperative behaviors. They try to look at, you know, they try to order these communication flows between some internal PCs and external servers, and then they try to detect these suspicious infection events. Bot sniffer also is similar, and bot miner. These are all popular approaches out there, and some more approaches are there. But most useful approaches, I believe, for detecting DDoS or bot attacks is aggregation. Right, so collect traffic which tend to be similar, and then you can aggregate the traffic and then detect this attack. For instance, common destinations, right? Similar payload, right? Structure of the payload is similar, or size of the payload is similar. Common platforms, right? Like Windows, Linux, Ubuntu, whatever. So all these are different aggregation methods you can use to kind of collect common traffic, right? So based on this, you can then try to figure out whether they belong to the same botnet or not. Okay. So what are the some possible other key factors for aggregating? Like you can have common destination, similar payload, internal host platforms, presence of scanning activity. If you see multiple one PC is trying to scan other PCs continuously, you might suspect that that particular PC might be infected with some bot. Then some common protocol behavior like HTTP, TCP, UDP, right? If you see a lot of these protocol go around in a given network, then you can suspect something. Common host behavior. And finally, you can apply spatiotemporal correlation, meaning that if multiple PCs in a given location are launching an attack at the same, then you can think that there is something wrong with these machines. Or if multiple PCs even in given location or in different locations are doing something at the same time, temporal correlation, then you can think they're doing something bad. Okay. Finally, DDoS attacks are measured by traffic volume. So the largest attack so far was on gaming servers, about 2.5 terabytes per second. Mirai was about 600 Mbps initially. It went up to 1 terabyte. And this year we have seen attacks up to 700 Mbps as well. Okay. And finally, DDoS attacks are real, and main for launching successful DDoS attacks, large scale infection is very important. Weak protocols and defensive postures of people not securing the PCs, or not having good defensive posture for enterprise servers or organizational networks help this. IoT has not made it easy because many devices with weak security are flooding the internet. So several defense approaches are there, like traffic inference, clustering, cooperative behavior, filtering, malware detection. These are all some known approaches for detection. Okay, so I'm now open for questions.
Thank you so much for your expert lecture, sir. Very enlightening indeed. We do have a number of questions, actually nearly 10 of them. So let's try to cover as many as possible. We have a lot of students thanking you for your expert insights. I would like to join them in expressing my gratitude. First of all, we have a question from Kamali, who sent it to me via email. She says, "This is a very interesting lecture, sir. Thank you. I'm curious to know if the recent increase in Instagram and other social media account takeovers and server downs of Instagram and WhatsApp might be through DDoS attack."
The takeover, you mean? So DDoS attacks are actually more network oriented. So if any application takeovers could also be, I mean, they're also possible. Somebody could hack into different servers, and because in the end it's a malware attack. So the compromise aspect happens first. So infections do happen. So if Twitter or Facebook, you see a lot of fake things. Fake comments or takeovers. I would believe that it can be possible through DDoS. Yes. But they might be stealth DDoS. That means they don't want this attack to go wild as such. They want to be hidden as long as they can.
Thank you, sir. Birendra and Varsha would like to know whether you would be willing to share your presentation.
Yeah, it is. It's, as I said, I'm not claiming any proprietary points. Only some points are. I have put in few things here and there. I'll definitely share them.
Thank you, sir. Reddy is asking the following. Is there any specific reason to exclude the scanning of IP address on ports 23 and 2323 for the Mirai botnet for scanning the IoT devices?
Nothing like that. So 23 and 23. So they are not excluded. If I'm not mistaken, they were actually the scanning happened on those ports. Let me just one reason. So I forgot why. I don't know right now. I think these are there's a 23 is privileged port used. I think some security services run on them or something like that. So that's probably the reason why these ports were skipped.
I understand. Birendra would like to know about APT attacks in an Indian context.
So APT attacks are stealth attacks. They're the opposite of DDoS. So I'm not very familiar with Indian APTs as such, but in India we have seen DDoS attacks in recently this year as well. Last year also on the power sector, power grids have been brought down. APTs are definitely they do exist, but because they are stealth attacks, unless one actually reports. I mean, nobody reports APT attacks. First of all, let me tell you, many people will actually undergo an APT attack, and I mean they will see that there is malware spreading. They'll detect it after 3-4 months of the spread, and then they will not realize that it has happened. Even then, they get embarrassed to even report it because it gives a bad picture of their own defensive posture. So this is something that I would say. So as such, so that means I wouldn't know about it if unless somebody came up and told me, okay, we had an APT last year or last week. So yeah, that's much I can tell you. In any case, whether it's India or US, it doesn't make any difference. The APT is an APT. So sorry. Yeah.
No problem, sir. Sorry for interrupting. Thank you so much once again. You were really generous with your time. We really hope to host your expert lecture during next year's cyber school as well. And on behalf of all our students who are expressing their gratitude in the chat, I would like to thank you for your really valuable contribution, sir.
You're most welcome, Mr. Adam, and all the students. Thank you for your great comments and questions. And if you have anything, you can always let me know.
Thank you. Samir is saying in the chat that this is the best presentation. Well, this is the end of teaching, so we saved the best one for last.
Thank you, Samir. Thank you so much.
Thank you so much, sir. This concludes the 2 weeks of teaching for the Indo-Dutch Cybersecurity School 2022. We just had 2 weeks of excellence in cybersecurity. Very excited to see your challenge solutions, and at the latest, I will see you guys at the wrap-up ceremony on the 25th of November. Make sure you tune in for Michelle's evaluation of the National Cyber Resilience Game next Thursday. Very exciting. Please keep logging in, keep playing the Cyber Resilience Game. So that the colleagues who are selected to be contributors on the report can have as much data to work with as possible. Until then, thank you so much again, sir. And I wish all our students a fantastic evening. Thank you.
Yeah. Bye. Thank you for inviting me.